Now look at this picture. Seeing this, can you tell me what is the angle between the two vectors A and B? Look at this. This is vector A, this is vector B. Two vectors are acting. What is their angle? 60 degree or 120 degree? See, the idea is when one vector ends and from that the next vector starts, then exterior angle, outside angle, has to be considered as the angle between the two vectors. Remember this point. When two vectors act in such a way that one vector ends and from that point second vector starts, then the exterior angle is to be taken as the angle between the two vectors and not the interior angle. Okay? Now, let us do vector operations. Vector operations are generally of four types: addition, subtraction, multiplication, and division. So addition of two vectors is just like vector A plus vector B, and it doesn't mean always this is A plus B. No. Then subtraction of two vectors, vector A minus vector B, doesn't mean always A minus B. That means it is not only the subtraction of their values, if 50 Newton, 30 Newton, minus then 20 Newton. No. Multiplication, vector A cross vector B and vector A dot vector B, we read them like this. These are the two types of vector product we call. Vector product multiplication. And division. Division of vectors. I have not written anything because vector A divided by vector B is you cannot understand this. I have written it in Hebrew. You cannot understand. See handwriting. So anyway, so this is meaningless. You cannot do vector operations like this by dividing one vector by other. Why? Because you can divide magnitude by magnitude, but you cannot divide direction by direction. So that becomes meaningless. So these are the four, out of which we are now interested about the first part. The first part is vector addition. Now vector addition has got certain rules. Out of them, there are two rules mainly, another rule is there. So total three rules. Law of vector addition using triangle. So law of triangle of vector addition. Law of vector addition using parallelogram. So law of parallelogram of vector addition. And if there are number of vectors, like you see there are two vectors only, A and B. If there are five vectors, A vector, B vector, C vector, D vector, E vector, then how we add them? Then law of triangle, first law I told, and law of parallelogram, we cannot apply them directly. So then we apply law of polygon. Anyway, so law of triangle is also a law of polygon. Later we will see them. First, let us understand law of triangle. So law of triangle, very important. Law of triangle. Law of triangle states that if there are two vectors, suppose vector A and vector B, this is vector B. See where I have drawn vector B from. Vector A ends, from that point I have drawn vector B, just like this. So the angle between the two vectors has to be considered as the exterior angle. So this should be the angle between vector A and vector B, exterior angle. So if we can represent two vectors by both by magnitude, that means length, told you, and direction, that is angle and arrow. So if two vectors can be represented by both by magnitude and direction in this way, then the third side of the triangle, third side means this point to this point, third side of the triangle represents the net result, that means resultant. Resultant is the net result of the vectors. So the resultant vector would be given by this third side from starting point to the last point. That would be its direction, like this. So the resultant vector would be something like this. I don't tell you to draw the arrow over here. Always try to draw the arrow at the end, like this. So this would be the resultant. Resultant vector is represented generally by R. It may be any letter, but generally it is R. So this is the resultant. That means if there are two vectors A and B are acting like this at an angle theta, then the resultant vector is R. Now how much would be R? R is a vector quantity, so it should have two things, that is magnitude and direction. We have to find these two things, magnitude and direction, for this resultant vector R. How to find that? Very tough mathematics is there, I'm telling you. I don't know whether we would be alive after doing this or not. Anyway, for this, we will draw a perpendicular from this point, like this. Is it a perpendicular? I shown this as a perpendicular. Okay, I'm redrawing this. Now, a perpendicular. Can someone tell me that this is vector B? Okay, but what is the magnitude of this? Magnitude means only value. Value is only B. So if I draw this triangle over here, this vector B is this one. So this has got a magnitude. See, I have put no arrows here. That means we are only interested about magnitude, value, length. So what is the length of this? This is vector B. So this is only B. Okay. This angle is theta. This angle is theta. Okay. This is 90 degree. So can we say that this is hypotenuse? And do you know that sine theta equals to perpendicular by hypotenuse? So perpendicular equals to sine theta into hypotenuse. So this is the perpendicular given by hypotenuse into sine theta. So this is b sine theta and this is base of the triangle. So that is given by b into cos theta. Why? Cos theta equals to base by hypotenuse. So base equals to hypotenuse into cos theta. Hypotenuse here is b. So remember this idea. Perpendicular equals to hypotenuse sine theta. Base equals to hypotenuse cos theta. So this is given by b sine theta, this length given by b cos theta. Let us put those values back to this. That means this is b sine theta and this is this much, b cos theta. Now, I told you this is going to be very tough. I am erasing this. Can we see a single large triangle? This one, right angle triangle. So can we apply Pythagoras? R square. We are going only after the values and students make mistake by putting this arrow over here. Don't put them, because when you are writing an equation, values, then don't put these arrows. We are interested only with their magnitudes, values, without arrows. So R square, hypotenuse square, equals to perpendicular square. Perpendicular is how much? B sine theta. Plus base square. Base is total how much? This was A already and this extended part has been B cos theta. So may we write it as A plus B cos theta. Perpendicular square plus base square. So base square means A plus B cos theta whole square. B square sin square theta plus here A plus B whole square sort of thing. This is A and this total thing is B. So A square plus B square, that is B square cos square theta, plus 2AB, 2 into this, so 2 into this into that, B cos theta. I told you this is going to be very tough. Think of this. After a lot of calculation and scientific research, scientists have found that sin square theta plus cos square theta becomes 1 if we take b square common from these two. So these two together will become b square common, sin square plus cos square theta 1 plus a square and plus this thing 2ab cos theta. That is how much? R square. So what would be R? R would be root over of that. So R equals to root over of a square plus b square plus 2ab, no, into cos theta. This much is R. Have we got this thing? Magnitude of this resultant. Direction. How to find direction? Let me tell you one thing. I earlier told you Direction means arrow and angle. Arrow is given in vector R. See this. This was drawn. So this is vector R resultant. Arrow is given. Now what to find? Angle of R. With what? With any vector, A or B. So I have erased B. So A is there still. A, are you there? Yeah, A is there. So A is there. So let us find angle of vector R with A. Let us call this angle phi. Any angle phi. Generally that is taken. So tan phi. You know, tan is very popular. That's why we are taking tan phi. We could have taken cot phi. Anything. Why tan phi? Because we know this thing. Perpendicular. How much? B sin theta. We know this thing. Base. How much? A plus B cos theta. So simply put the value of tan phi. That is B sin theta divided by A plus B cos theta. So these are the two things. This is the direction and this is the magnitude. So resultant R is given by this magnitude and this is its direction. We will do a numerical, a small sum to understand this.